Okay, 2.11, this is our review for quiz number 2 on polynomials. We have a polynomial that is listed here above, and they're asking several questions. How many roots or solutions does it have? This is a 6-degree polynomial, so it will have 6 roots. Given that 1 plus I is a root, give another root. 1 plus I is a complex number. We have a theorem that is about complex conjugates. If 1 plus I is a root, and if the polynomial has all real coefficients, then 1 minus I also has to be a root. Given that negative 2 minus root 2 is a root, give another root. We have the irrational conjugates, so if negative 2 minus root 2 is a root, then negative 2 plus root 2 also has to be a root or a solution. Give one real rational root of this polynomial. Let's add the coefficients. 1 plus 4 is 5. 5 plus 2 is 7. 7 minus 1 is 6. 6 minus 4 is 2. 2 minus 2 is 0. So x equal 1 is a root of f because the coefficients add to 0. Why is x equal 5 not a possible root? Okay, the only possible roots are plus or minus 1, the factors of 2 over factors of 1. So 5 is not a possible root. Continuing on, list all possible rational roots for this polynomial. So it is going to be plus or minus the factors of 8 divided by the factors of 12. So that is going to be plus or minus 1, 2, 4, 8 divided by 1, 2, 3, 4, 6, and 12. So this is going to be a pretty long list. So it's plus or minus. Let's look at every number in the numerator divided by 1. So 1, 2, 4, and 8. Every number in that numerator divided by 2. 1 half. 2 halves is 1, that's already on my list. 4 halves is 2, that's on my list. 8 halves is 4, that's already there. Let's divide every number by 3. 1/3, 2/3, 4/3, 8/3. Now let's divide every number by 4. That's 1/4. 2/4 is 1 half. 4/4 is 1. 8/4 is 2. Now divide every number by 6. 1/6. 2/6 is 1/3. 4/6 is 2/3. 8/6 is 4/3. Divide every number by 12. 1/12. 2/12 is 1/6. 4/12 is 1/3. And 8/12 is 2/3. So this is the entire list. These are all the possible rational roots for that polynomial. Given that x plus 7 is a factor of this polynomial, write the f of x as a product of its factors. So that means factor this polynomial. So, and list all of the roots. So first of all, let's look at all the possible roots. It's going to be plus or minus the factors of 21. So 1, 3, 7, and 21 divided by the factors of 2, which are just 1 and 2. So this is plus or minus, sorry about that, let me back up. I didn't need to do that. They gave me that x equal negative 7 is a root, or excuse me, x plus 7 is a factor. So I go ahead and start. So sorry about that. Waste of time. So x cubed, 19x squared, 32x minus 21. So if I bring down the 2, multiply, I get negative 14. 19 minus 14 is 5. Negative 7 and 5, that's negative 35. Subtract to get negative 3. Negative 7 and negative 3 is 21. Add those numbers to get 0. So I know that f of x and is x plus 7 times 2x squared plus 5x minus 3. So I need to factor 2x squared plus 5x minus 3. So 2x squared plus 5x minus 3, which means I need two numbers that multiply to give me a negative 6 and add to give me a 5. So those numbers would be a negative 1 and a positive 6. Multiply to negative 6, add to 5. This is 2x squared minus x plus 6x minus 3. Factor out the x, 2x minus 1, plus factor out the 3, 2x minus 1. So this is x plus 3 times 2x minus 1. So my final factorization is f of x equal x plus 7, x plus 3, and 2x minus 1. What are all the roots and solutions? Those are x equal negative 7, negative 3, and 1/2. So those are the three solutions to that one. Next polynomial. List all the possible rational roots and then write f as a product of its factors. That's the complete factorization. And list all of the roots. And then we've got to show all of our work for this. So the possible rational roots, those are plus or minus the factors of 2 divided by the factors of 1. That's a pretty short list. So this is plus or minus 1 or 2. Okay? So let's just take a look at this. Let's add the coefficients first. 1 plus 4 is 5. 5 minus 8 is negative 3. Negative 3 minus 3 is negative 6. Negative 6 plus 4 is negative 2. Negative 2 plus 2 is 0. So I know that x equal 1 is a solution. So let's start with that. So let's start with 1. And I've got 1, 4, negative 8, negative 3, 4, and 2. This 1 corresponds to my x to the 6, so 6, 5, 4, 3, 2, 6, 5. So I'm sorry, I'm missing a fourth degree, so I got to take care of that. So I almost made a mistake there. So that is 1, 4, 0, minus 8, minus 3, 4, and 2. So just to get in the habit of checking, this is my x to the 6th, x to the 5th, x to the 4th, x cubed, x squared, x, and constant. Okay, so now that should work for us. If we bring the 1 down, 1 times 1, add to get 5, add to get 5, 1 times 5, negative 3. This is negative 3, that's negative 6. And this is negative 6, negative 2, and this is negative 2, 0. Okay? So it tells me that now I've got the 6th degree down to a 5th degree polynomial. So this means that x minus 1 is a factor, x equal 1 is a solution. Okay? Now, so I've got it down to 5th degree. I've got to get it all the way down to a quadratic. So I've got 3 more of these to go. But luckily, this list is pretty short. Okay, so it's either going to be 1, negative 1, 2, or negative 2. Let's see if 1 would work again. First of all, to know that, let's just add these numbers I see right here. 1 plus 5 is 6. 6 plus 5 is 11. 11 minus 3 is 8. 8 minus 6 is 2. And 2 minus negative 2, that does not work. Let me double check that. So 6, 1 plus 5 is 6, plus 5 is 11, minus 3 is 8. 8 minus negative 6, that is 14. Yeah, it's not going to work. But if it would be no harm if you tried this again. So if I tried 1 again, I can just rule it out. So add this 1, you get 6. 1 times 6, add to get 11. This is 11 minus 3, this is 8. Add this to get 2. And sorry, I must have made a mistake. 1 times 2 is 2. So it does work. Something was wrong in my arithmetic of adding those. Let me try adding that row again just to double check myself. 1 plus 5 is 6. 6 plus 5 is 11. 11 minus 3 is 8. 8. Oh yeah. 8 plus negative 6, that is 2. 2 minus 2 is 0. So sorry, I'm having a bad day on the arithmetic. So x minus 1 is a factor again. So we have x minus 1 is a factor. X equal 1 is a solution. So I've found that working 2 times, okay? So that means that what I'm left with at this point, this is x to the 4th, x cubed, x squared, x, and constant, okay? Now, I can add all of these numbers up, and I know that they do not add to 0. I can see that because they're all positive. So 1 is not going to work. So let's just move on to negative 1. So I'm going to try negative 1, and let's see if it works for 1, 6, 11, 8, and 2. Okay? So bring down the 1. That gives me negative 1, 5. Multiply here, and I get 6. This gives me a 2, negative 2, and 0. So that means that x plus 1 is a factor. X equal negative 1 is a solution. Okay? Now, I've got this down to this is x cubed, x squared, x, and constant. Let's try negative 1 again and see if that works. So let's just come over here. So negative 1, and let's look at 1, 5, 6, 2. So if I bring down the 1, negative 1 times 1 is negative 1. 5 minus 1 is 4. Negative 4, this is 2. Multiply here, negative 2, and you get 0. So this means that x plus 1 is a factor once again. X equal negative 1 is a solution. And then what I'm left with is this is x squared plus 4x plus 2. So I've got x squared plus 4x plus 2. And numbers that multiply to give me 2 and add to give me 4. Okay, there are no numbers that do that. Okay, so there are no numbers that do this. So in order to find the roots here, I'm going to have to use a quadratic formula. So x is negative 4 plus or minus 16 minus 4 times 2. All of that over 2. So this is x equal negative 4 plus or minus, this is the square root of 8, all of that over 2. And this is x equal negative 4 plus or minus 2 root 2 over 2, which is negative 2 plus or minus root 2. Okay, so I now have all the solutions. The solutions are x equal 1, negative 1, both of those worked twice, and then I've got what, negative 2 plus root 2. You could list it like that, negative 2 plus root 2 or minus root 2 or plus or minus. Those are all of the roots. And then my complete factorization was f of x equal x minus 1, x minus 1, x plus 1, x plus 1, and then I had what, x squared plus 4x plus 2. So that is my factorization. You could have written this as f of x equal x minus 1 squared, x plus 1 squared, a squared plus 4x plus 2. Okay? So we have all the roots and we have this guy factored. Let's look at the next one. So this one is sort of, you've been given a gift. We start out with a 4th degree polynomial and they have found, it looks like, a couple of roots for us. So this means that x plus 7 is a factor. And it also means that x minus 12 is a factor. And this is x to the 4th, x cubed, x squared, x and constant. And after 2 synthetic division, this is x squared, x and constant. Okay, so really all I need to do is just figure out what is x squared plus 2x minus 2. Are there numbers that multiply to negative 2 and add to 2? There are not. Okay, so if I set this equal to 0, then I get x is equal to negative 2 plus or minus the square root of b squared, so that's 4, minus 4a c over 2a, x equal negative 2 plus or minus, and that is going to be 4 plus a, that is 12 over 2. So x is negative 2 plus or minus 2 root 3 over 2, x equal negative 1 plus or minus root 3. Okay. So all of the roots are x equal negative 7, x equal 12, and x equal negative 1 plus or minus root 3. So if I have it fully factored, then f of x equal x plus 7, x minus 12, and then remember I've got the roots 1 plus root 3 and 1 minus root 3. So this is x minus 1 plus root 3 and x minus 1 minus root 3. So you could write it like that. Another way to write the final form is f of x equal x plus 7, x minus 12, x minus 1 minus root 3, and x minus 1 plus root 3. Okay. So that's our complete factorization of the polynomial and all of the roots. Give the equations of the polynomials of least degree with real coefficients and zeros as given. Okay, so if the zeros are 2, 3, and 1, that means that f of x is going to be x minus 2, x minus 3, and x minus 1. So f of x equal, if I multiply the first two terms together, I get x squared minus 5x plus 6 times x minus 1. So when I do this operation, I can do it with a chart. So multiplying that by x squared minus 5x plus 6. X times x squared, that's x cubed. X times minus 5x, and this is 6x, and minus x squared plus 5x minus 6. So if I do this, my final answer will be x cubed. And it looks like I've got minus 6x squared plus 11x minus 6. Okay, that is my cubic polynomial that has zeros of 2, 3, and 1. polynomial that has zeros of 1 and 2i. So this polynomial, so this is f of x equal x minus 1 and x minus 2i and x plus 2i. I have to have that. If 2i is a root, negative 2i has to be a root in order for this to have real coefficients. So the best two things to multiply here together first are these two. Okay, so when I do this, this is, so x minus 2i times x plus 2i. That is going to be x squared minus 2xi plus 2xi minus 4i squared. The middle terms, these go away, and so I'm left with x squared, and this is minus 4 times negative 1, so this is x squared plus 5. Sorry, x squared plus 4. So x squared plus, keep wanting to write a 5 down, x squared plus 4 is what that is. So f of x equal x minus 1, x squared plus 4. And then to multiply these together, I can FOIL this. This is going to be x cubed minus x squared plus 4x minus 4. Okay. So that is the cubic that has roots of 1 and 2i, but it also has to have a root of negative 2i in order to have the real coefficients. And let's look at the last one. I have roots of 2 and 2 plus root 3. So f of x has to equal x minus 2. And then if 2 plus root 3, if that is one solution, then I also have to have 2 minus root 3. Okay? So what are the factors? X minus 2 plus root 3 and x minus 2 minus root 3. Okay? So this means that I've got x minus 2 minus root 3 and x minus 2 plus root 3. So I've got to multiply all of this together. So let's start by multiplying these things together. Okay? And I can use a chart to make that happen. So let's do that right over here. So if I'm going to have, let's just see, x minus 2 minus root 3, and then I'm going to have x minus 2 plus root 3. Okay? So x times x, let's just change color here. This is x squared, x times negative 2, x times root 3. Move to the second one. I get minus 2x, 4, and minus 2 root 3. Go to the next row, I get minus x root 3, and I get 2 root 3, and then I get minus 3 when I multiply negative root 3 times root 3. So if I look at this, I've got some nice cancellations. This cancels with this, and this cancels with this. That's what I expect, to have no radicals left. So this evaluates to, what, x squared, and it looks like, what, minus 4x plus 1. So I've got to figure out what is f of x is equal to now x minus 2, x squared minus 4x plus 1. So I can do this grid all over again. So x minus 2 times x squared minus 4x plus 1. Multiply here, I get x cubed minus 4x squared plus x minus 2x squared, and this is 8x minus 2. And when I combine all of this, my final answer will be f of x equal x cubed minus 8x squared plus 9x minus 2. And that should be the final answer. Sorry, there's a mistake here in this last one. This is not a minus 8. When you add the negative 4 and the negative 2, that is a minus 6x squared. So final answer for this guy, x cubed minus 6x squared plus 9x minus 2. Also, I was taking a look at the answer key. If I look back at this one right here, we can write the final factorization based on all the roots. So if I look at this one, I can write my final factorization as f of x equal x minus 1 squared, x plus 1 squared, and then remember I've got the roots of what? Negative 2 plus root 2 and negative 2 minus root 2. So this is going to be x plus 2 minus root 2, x plus 2 plus root 2. Okay, so the way that comes into playing, so remember, if you've got negative 2 minus root 2, then x minus negative 2 minus root 2, that's x plus 2 plus root 2. That's a factor. And then if you've got negative 2 plus root 2, then x minus that is x plus 2 minus root 2. That's where those two factors. So that is the complete factorization that comes from having all the roots. Okay? So once you have all the roots, you should be able to write all the factors, rational, irrational, and complex.